then subtract, then appear multiplication, which is connected with addition, distribution law, then division, so on. But this way was not so simple as it seems now. For example, about 1,000 years ago, in Europe, men who can take division, use the division with such numbers, was very high level scientist, and of course he received a degree of Doctors of Science.
Today.
Then, after arithmetic operation, begin to use other functions which we now knew as elementary functions. But that was so not simple way. For example, logarithm was using about 15th century. Arabic system, which replace Rome systems, number systems, appear about 12th century, and very much try Fibonacci. Very try to provide these systems. I think that he was very happy do this work, because he understood Arabic system and usual way which we use now, working with numbers. And of course, he understood that he must teach all of people use these systems. And all this way, some functions, operations is also functions. For example, addition is functions to arguments. Appear in our history only those which go through natural selection, so some kind of natural selections. For example, elementary functions, hyperbolic functions, hyperbolic functions, sine, cosine. I'm not sure that this symbol used here, but this is elementary functions. But some problems, some good properties, excellent properties of these functions lead to let these functions go through that selection, natural selection. And if we remember my lectures, I introduced also some symbols, for example, such symbols for operations and the other of them. I am sure that at most, that at least pair of them will go through natural selection, because it's widespread problems connected with taking into account geometry, and this is a good thing for a lot of mathematicians and applicators. Last lecture I tell you about functions, and there are are the atomic functions. These functions, I am sure, also shall go through that nature selection. Because if you remember, when we consider the problems where our functions are using, we meet with such problems. Suppose we have structure solution, some boundary value problems, and here is operator which take inside functions which take into account geometry, and some indefinite functions, polynomial or some kind of polynomial. And when we want have such polynomial that have good approximation properties like usual polynomials, and at the same time have property locality or finity, like splines, finite splines, and trying to such approximation properties, we connected in these functions, such kind of functions, possibility to have infinitial continuous, like usual polynomials, approximation property the same like polynomials, because any polynomials we can write in such combinations. Polynomial any degree, we can in such combination represent such combinations. So properties, polynomials, and this linear shifts of atomic functions give us possibility, have the same approximation as polynomials. But these functions are finite functions, have finite support, and when we shall using such combinations, these functions, we can receive, when we shall changing any coefficients here, we shall changing polynomial only locally. But if we changing coefficients in polynomial, we're changing all polynomials. So in these functions, we connected two such good properties: polynomials, infiniteness, infinity time differentiable, and finite like splines. I am sure that such kind of functions, there are several another atomic functions. I am sure that such functions also go through natural selections. I am sure, but I don't know exactly. But I am only sure that it will be. So this way, thinking in this way, I and my colleagues begin to decided to through all the way which went mathematicians when in their developing from the very beginning. And if of course we are not first who think in that directions. For example, Kronecker wrote that O0 and 1 are given by God. All other is other received by, created by hands of men. Of course, they think about it, but was very hot sunny day, and I was ill and must hide in the shadow, and it was nothing to do. And I began thinking about this problem. What mean chronicle when we say those? He said that whole numbers are given by exactly by God. But if we think about it, we see it. So we have O, 1, and operation addition, which give us receive all other. But addition, of course, from ancient time, they understood addition, which also seem given by God. But about beginning, about the final and beginning of our century, some scientists begin to condemn according that we must use addition in any cases. For example, Helmholtz writes that show examples. For example, if I take 1 liter alcohol and 1 liter water and mix them, I don't receive 2 liters of the water. Some part of alcohol, some go out. So, usual addition. Usual addition, not working everywhere. But at the very beginning of our century, physicists received problem which some considered as crisis of physics. When they decided to use classical Newton mechanics to phenomena when there are properties, there are velocities near the light velocity. The problem was the Newton's mechanical take into contradiction with experience, but at that time, Einstein and some other scientists which discussed this problem suggested another way adding velocities. And at the time, they received such formula. Let us notice this addition in such way. Where x and y are collinear velocities, and when we add in this way collinear velocity, we never receive a result more than c. Module this result, of course. Einstein even considered this formula and tried to find some another calculus using this formula. He took this formula and began considering its algebraic properties. But now I shall say about that. If we consider in what way using addition we receive other operations and functions, we can notice that this addition have properties, group properties. Existing identity of the group, in that case this is 0, then association law, and for any x exists such x that x plus x is 0. In that case, x is minus x. This is properties of usual arithmetics. Then multiplication in usual arithmetics were introduced like group addition. When we, for example, 4 and 4, sometimes we receive multiplication, 4 sometimes. For multiplication, we have such properties. The same kind. But only identity is another. In that case, and experimentally we found that addition connected with multiplication, distributive law, that we have in usual arithmetics. When these operations are introduced, then subtraction is received like inverse operation for addition, division like inverse operation for multiplication, and then if we have notion functions, we have introduced derivatives, nothing else, and limited functions, two notions which not connected with operations, any operations. Then we introduce limit, then integral, we can introduce, of course, using only arithmetical operation. Then we receive differential equations, and solutions of differential equations are all elementary functions, and with ordinary coefficients. Other give us special functions, so on. All analysis going through this O and 1 and addition. In that way, Kronecker or other scientists considered construction of mathematics. But if Einstein wanted to construct mathematics using this operation, we must to find also multiplication, connected distributive law with this addition. For such construction, we begin consider, is this a group like this Abel group? And of course, it is clear that first law is here. In that case, x plus 0 is x. That law we can check. let us notice such notion. Let us introduce for shorthand. Yes, you're right. We receive such formula. Yeah. Of course, this is symmetrical according all arguments, so this is we see that this law is also introduced, and this is also. So Einstein that check he understood that he has group, but for construction, according to this scheme, he must be found the multiplications. This is start position from which I begin to think. We have, suppose I want to do Einstein. Then I must to take distributive law for these operations. Suppose multiplication denoted in such way, according to this addition. Then we must to write such distributive law and if I want to find this operation, I must receive formula for x OZ or y OZ. But in what way to solve such equation? I never saw such equations and even did not know how to solve any equation of that kind. But then I understood that this is not simple equation, this is identity. But if this is identity, I can differentiate it for any arguments. So, next way was, let us this identity at first take derivatives according x. Then we receive here is x. Then and that must be equal. Что?
Непонятно. Что-то мы не понимаем обозначение.
I take derivatives, this identity of x.
This means derivative with respect to x.
This is functions. This simple derivatives according x.
I see. That's right.
Or the same symbol del dx. But we use such we use such notion in our country. So let us write in the way you like. We have such formula. It is easy to understand, it is easy to check derivatives. I simply remember this formula. Because this is such expression. X plus z.
Нет, там умножить.
Here.
X плюс y. X плюс y.
For example, x.
Первое.
Да, x plus y.
X плюс y. И там
Such kind formula. Here, when we shall take derivatives, we receive the same kind of expression.
How did you manage to get a z?
знаменатель X y.
Yes, of course. Thank you very much, Tanya. She write me conspect this lecture, so she knew exactly all. Она спрашивает, какой гадости сказал. Then this is the same kind of formula. Then we shall consider this formula. Then if we do the same according y, we receive the formula the same kind. Then, if we divide this formula on this formula. These were shorted, and we received, instead this expression, we took this formula, so we received this denominator in that formula, and that will be the same, so they also shorted. And we receive this will be
There's going to be a square over there. Square. Consistent.
here square. Y.
I mean up there.
В квадрате и в числителе y. О,
Показывает, да, вначале обратите
I'm just looking at it naturally. It's inconsistent.
So we receive such formula, and it is easy to see. It is easy to see the derivatives.
I'm trying to understand.
That
Пытается понять, почему нет симметрии между этим и этим.
here,
Или здесь квадрата нет, еще одно.
ah, of course, but these denominators are shorted, so I did not think about them. And we can see that in that case we can divide derivatives. We can write this is depends only on y and z. This depends on x and z. So we can write that this is some functions of z. We can consider, for example, this equation, ordinary equations, because y is not here, and we have x derivatives according x and functions according z like parameter. We can solve these equations, and we of course must to remember that x multiply 1 is x according properties of the multiplication, and x multiplied O zero. These constants are given by God, so we can use them without thinking. This equation we, of course, can solve, any of us, and as a result, we receive such functions for multiplication. Exponent, these multiplication logarithms, it is seem very strange that starting functions have, don't depend on any elementary function. This is arithmetic expression, only arithmetic operations. But from this distributive law, we receive formula which depends on exponent, logarithm. I think that if this formula was more simple, then Einstein and the mathematician who were near him also find this formula. So we receive now all needed for constructing some kind of multiplication. Because these properties and these properties and these properties are the same, all the same. So if we substitute usual properties, usual operation instead new operations, then all calculus, nothing notice. All formula of calculus will be the same. It will be algebraic isomorphism according with usual calculus and new calculus. For example, if I write such formula in usual calculus, in new calculus, I must write x nu plus nu 2. Nu 2 is, what is it, nu 2? This is 1 plus 1. This is not equal usual 2. So on. Let us notice y and 2 degree plus. Multiplication, nu 2 here also. It is strange, but this is x degree 2, x degree 2. Yes, definition. We can't write usual multiplication. If I shall write here that way, this will be x. But now we use another multiplication, so another notion. So on. Any arithmetical formula which is true in another calculus is the same form. This is algebraic isomorphism, law of algebraic isomorphism, which is due to equivalent properties, these operations and new operations. we shall call this operation relativistic operations according to their origin from theory of relativity. But this is first step. Then we go the same way, or we can consider differential equations. For example, derivative we can introduce the same way. Consider limit f x plus h minus f h x divided new division. For example, such way, x
Why h squared?
Excuse me, please. I begin to think about another order derivatives. That way we can introduce derivatives. For example, derivatives noted such way, and another second order derivative, so on, integrals, so series, all calculus. New elementary functions, for example, if I consider such kind, I'm afraid to write in our way, if I consider such and take such additional condition, I receive exponent, new kind of exponent. That is, will be a solution to this equation. Of course, I can write expression. Meanwhile, this limit I can calculate and in usual arithmetics, in usual, and receive usual formula more. If you want, I can write it, but I think that is not done now. So we receive new calculus, and in this calculus there is a greatest number. All formulas which we receive don't give us the number greater than C. And when we constructed this calculus, we never use that this is exactly light speed. Never. So we can consider instead some number which we want to declare 10 or 10 in any degree. This idea constructed calculus using this operation appear not only in Einstein brains, but after I published my first work, I received the letter from one Indian scientist, Avinash, which sent me his work, a set of new integers, where earlier than I, about 7 years, he takes the same idea. He writes that there is not any physical. He is working in Plasma Physics Institute research laboratory in India. He says that in physics there is not infinities values. This is a total charge of the universe, total mass of the universe, are finite numbers. And if physical theory use infinities, that is not theory. This is full mistakes, different kinds. theory. He writes, total mass of the matter in the universe is finite and total charge in the universe is finite. This implies that we must try to trace the origin of the concept of infinity, of magnitudes, and must try to eliminate it. But he declared largest number 10, and using this operation, create the table of multiplications and nothing else. And he wrote me that he was very happy when he wrote my results. He also wrote me that one was in many institutions of the world. In India, I got in touch with mathematicians at Tata University for Fundamental Research, Bombay. We did some progress in working out the complex number field for integers. In between, I presented this paper. I was in Culham laboratory, was in Oxford University, mathematics department. I talked to a number of people about this idea. Everybody appreciated it, but could not suggest how to proceed from here. In 1993, I was in USA, Texas University, and in International Institute Trieste. I gave a talk of this topic. Professor Salam liked this idea. Then he also was in the Soviet Union, Professor Sergeyev, Galeev, Kadamtsev. He have conversation, but did not know what to do with this idea. I did not knew about his attempt to go this way, but we begin to have changing letters. So I knew what he do now and what I do now he knew too. This is all about calculus which based on this operation. But another step to consider all kinds of operations which can be used for construction such calculus. Then it was noticed that if we introduce such notions, then multiplication we can write in more shortest way, and it is easy to see that if we take such notice, it was found by accidentally these functions. But okay, that multiplication I can represent in such way. So if you use such two functions, they are inverse. This is that multiplication can be represented such way. And okay, that not only multiplication, all operations can be represented through these two functions.
What is the meaning of a tau without a circle?
Tau is... Yes, thank you very much. You must look through it also. And it was happened that not only multiplication, but any relativistic operation. For example, if I write here such symbol, here will be usual plus, minus, here minus relativistic, here minus division relativistic. I must usual division. So it happens that all operations can be represented through, in fact, one functions, because tau functions can be found as inverse operations, and all operations can be represented through usual operations. If we consider what is the functions, it is easy to see that this is map here to such interval, and if I draw the graph of the new text, I receive in this point and point 1, 1. This is point exactly. Then this is greatest number. So graph is the same way for nu. The graph of the tau for the tau is, of course, such way can be received. And if we can say that nu is the axiom of the relativistic calculus. Using only this axiom and usual operation, we can represent all relativistic calculus. But if we take instead, nu is x, tau, of course, is x. So if we take such axiom, we receive usual calculus. And it seems that if we take any function of that kind, which is going through these 2 points, and these axioms are infinity set, we can receive different kinds of calculus. And indeed, if we shall take such axioms and we can check all these properties and receive the calculus. Professor Tanya writes a lot of different kinds such functions which we can use for construction of calculus. For example, two parametric family of such axioms is parameter epsilon delta. If you consider such two-parametric family of curves, all they have needed properties, and if you take delta 0, we receive usual calculus, and if delta is 1, then we receive calculus with greatest number m. In that case, we have horizontal symptom.
These are alternatives.
What?
These are alternatives. If I use this function, you get there. I end up with arithmetic that satisfies all these other axioms, but
all axioms we are satisfied because when x is 0, this is 0. When x is 1, this is 1. And we have axiom such kind functions. Some of them, when delta is 1, we have such calculus. When epsilon is, when delta is among this axiom, there is not relativistic axiom.
Какой смысл в эпсилоне и дельте?
Epsilon and delta are constants. Changing this constant, we can receive a set of axioms which we can use for constructing calculus. For any pair of x and delta, we can have calculus. For what we needed in such families, because we wanted to try some approximation, some applications our calculus for cosmos problems. Any axioms, any calculus, any axioms in mathematics must be go from experience. Usual mathematics was created due to experience which had all humankind.
But
yes?
This produces now an infinity of possible arithmetics with numbers which never exceed m.
Right.
Yes, not only. In this family, there are some, if delta is 1, when delta is 1, in that case, we have greatest number. If delta is not less than 1, we receive calculus which axioms resemble this axiom for usual calculation, which is go to infinite. So we have some possibility to create, to check from this two parametric family some which we wanted connected with experience. The large experience in far cosmos were created in the school, Chlenov member Russian Academy of Science, Professor Troitsky. He died, this year. He was 83 years old. We have a conversation with him. My people we met with him, and we have changed letters. And he gave us his papers, and we shall possibility to took from these axioms which are more exactly correspond with experience. But happened such strange way that the most good calculus for cosmos is give such formula, the same formula as for speed, but in that case, greatest number is not speed of the light, but is diameter of our universe. All astronomicians, those who think that our universe is widened, and those which protest from this idea, those who think that our universe appeared due to Big Bang in about 15 million years ago, and those he developed their theory from this Big Bang, all have such number. About this is about megapascal. This is about something 3-10 meters. And if we took into consideration this calculus and connected with experiment data Troitsky and his school, we receive for redshift. You know that our far cosmos objects have shifted their spectrums in the left side. We receive for non-motion objects from on rest in far cosmos, that they have exactly that redshift as they observed. So it seems that the idea about widening our universe is not true. And as a sequence, idea about Big Bang in some point in the space without any matter is also not true. It seems that our idea is that the universe exists all the way, or ever, or was created in the time which we can write in the Bible. I think that our idea, physics, can improve much more lighter, much more faster than this strange idea about Big Bang. Nothing is not around. Of course, there is not space. And there is some point. Where is that point if there is not space? And what physical forces which create the space? But physicians guess they create the theory in what way happens this Big Bang. I think that our theory will be much more better proof. But I will let us think now. We stop thinking in that direction.
Does the exponential function have a simple form?
Exponential functions.
I mean, this is the one right here, the one that
No, not very simple form. I pretend to study the exponent. I don't have the formula here. I can find this formula. I have in laboratory. I have preprint. There is formula for exponent.
You also have written a book about this calculus?
Not books, only papers. One of these papers I can give you, and a pair of these papers I can give you. Ну, посмотрите, это полная статья или нет? Просто проверьте, она целая статья или нет. Да нет, вот посмотрите эту статью, она вся или нет. От начала до конца.
Ну, то она на одной странице.
I can give you in English, so I have papers in Russian and in Ukrainian, but this is translated from Russian journal.
Okay.
What?
Oh, okay. Maybe I can make a copy and to give it.
Yes, I give you.
Okay.
I have copy.
Oh, you have.
And
Okay.
this is my paper in our Ukraine, but in our country we begin write papers in English. Because in Ukraine nobody reads them. think that other application will be, but for other application we must find the experience, and we must find the physicians or mechanics or specialists which can understand this mathematics apparatus. And this is problem. I hope there are special situation where we cannot, we don't mind, we must use such kind of calculations. For example, we knew that there is the nearest temperature minus I don't know how to write in Fahrenheit, translate Fahrenheit in Celsius is the same problem as rim symbols in Arabic. We can't understand in what way we can transform. But if we have nearest number, then of course in vicinity of this numbers, nearest number, there is not true Archimedean axiom. Archimedean axiom, which we use in usual calculus, says that if you have some quantity, then adding this quantity, we can receive a number greater than any other, or in other side, less than any other. So I must find some physicist who knew theory in that nearest temperatures and teach him this calculus, and then try to consider what they have there. I suppose that theories which he used is not exact, because, for example, last time appear materials with high high conductivity, but they can't. In our town, special institute, they can't understand what from their physical image. They can't find answer. What such happened? But maybe this calculus helps them. Or else maybe in our Chernobyl sarcophag something is going not according theories existing, but maybe we must consider such kind of calculations there, because it is a lot of strange questions. For example, if Einstein considers this addition and use, when he considered, for example, his formula, he used usual multiplications, but he have not usual addition. And there are a lot of problems there. Some young scientists begin to deep there and something find very interesting. But I don't want to say beforehand, because I don't know, maybe their way is mistaken. So we have a lot of questions which appear after such construction, like I told you.
So if I understood correctly, this exact new calculus takes place when you come close to the largest number.
Yes.
When you are far away from the largest number, you can use regular.
Maybe we'll say Russian.
Насколько я понял, вот этот новый калькулус вступает в силу, когда ты приближаешься к самое большое вещество.
Он-
Но когда ты далеко от этого вещества, ты можешь пользоваться
Most no,
обычным
but this calculus is true in that case, in far away from here. For example, if these distances are small according to the largest distance, or if here is speed and when x and y are smaller than speed, this is almost zero, and we have usual.
But in many engineering theories,
Yes, of course.
engineering theories,
Yes.
there
So,
are maximum constants,
yes,
material constants,
yes.
or maximum stress for this material,
Yes,
after
yes.
which
So,
everything changes.
yes, so theory must be like in Newton-Einstein case. Theory, Newton relativistic theory is transformed into Newton theory when speed are much more less than speed of the light. Nothing else. I thank you very much for your attention. I finished my lectures in Madison University, and I'm very grateful you invited me, and I'm very grateful all of you. I'm very glad to have contact with you, and for example, you say, you put questions, you remarked my mistakes, and of course I shall try to transform myself in better English, in better attentiveness and any other qualities.
You're perfect already.
Excuse me for my bad English, for my mistakes, a lot of them. And thank you very much.